In 1980s, there were several different HDLs, hardware description language, in use, but each had its own syntax and semantics, which made it difficult to exchange design information between different design tools and environments. The United States Department of Defense recognized the need for a standard HDL that could be used across different design tools and environments, and VHDL was developed to meet this need. Imagine you are designing a car. Before building it, you draw a detailed plan showing how the engine, wheels and other parts connect. VHDL does the same, but for electronic circuits like those found in computers, phones and even robots. VHDL is VHSIC hardware description language. VHSIC stands for Very High Speed Integrated Circuit. The language was developed for the US military in 1980s and has been standardized by the Institute of Electrical and Electronics Engineers IEEE as IEEE Standard 1076. The latest version as of now is IEEE Standard 1076 2019. So VHDL lets you describe how digital systems like adders, counters or even processors work. First thing comes is simulation. You can test your design virtually before creating physical hardware. Then comes the synthesis part. Once tested, your design can be converted into hardware like an FPGA, field programmable gate array or ASIC, application specific integrated circuit chip. Now imagine we are making a digital light switch. Our goal is when we press the button, the light turns on. When we release the button, the light turns off. So here is the VHDL code. Now what's happening in this code? The first step is to define the switch, which is the circuit. Here we have entity. This is our light switch and it has a button which is an input you can press. Here we have the light which is output that glows, and this is the entity which ends here. Then we describe how it works. The architecture inside the switch we use, which is inside this begin and end, we use a simple spell. Light is less than or equal to button.